So this video is going to focus on practicing the activity of synthetic substitution. So in the last video, I just introduced the concept of synthetic substitution and how to do it. And now we're going to see a couple more examples that are a little bit different than the last example and just practice doing this together. So let's take a moment to check out this polynomial that we've got. We've got this polynomial function f of x equals negative 2x to the fourth minus x cubed plus 4x minus 5. So let's take this in. We've got a quartic polynomial because the degree is 4 and the leading coefficient is negative 2. And I want you guys to notice again that this is in standard form, which is the way we like to see it. And check out what's happening to the exponents as we move from left to right. We see that we're counting down. We're going 4, 3, the exponent on this x is understood to be 1, and then there's x to the 0 technically on this constant. Okay, so do you guys notice that we're missing a term with x squared? So that means we have to treat this a little bit differently than the last example that we did. So you need to write down the coefficients in order of decreasing exponents, as in order that they appear because this is in standard form. My my degree 4 term has a coefficient of negative 2. My next term, the cube term, has a coefficient of negative 1. Because there's no number there, it's understood to be 1. Okay. My next term with x squared, remember, isn't there, so I have to put a 0 there. That acts as a placeholder, and you'll see why this is important. Okay, so, and then my linear term 4, and then my constant negative 5. So I know I've already got this set up for you, but later on you're going to be setting this up yourself, so I thought it might be nice for you to see how this looks when you're setting this up for yourself. So we're trying to actually do f of negative 1, as in plugging in negative 1, so we put that here, and we go through and we do the same thing that we did before. So drop down, and once you've dropped it down, you're always multiplying what you get here by the number out here. Okay, so negative 2 times negative 1 is positive 2. We add these terms because that's positive. Negative 1 plus 2 is 1. We multiply again by this term out here. So 1 times negative 1 is negative 1. 0 minus 1 is negative 1. So every time I'm multiplying and adding. So negative 1 times negative 1, I'm multiplying. I get positive 1. I'm adding 5. I'm multiplying 5 times negative 1. And then because this is negative, be careful, negative 5 minus 5, it is not 0, it's negative 10. Okay, so remember that thing that you get at the end, this is your function value. Okay, and if we actually checked this doing direct substitution, it's a little bit more work. So let's go ahead and do that real quick, kind of off to the side or down below. So I've got my direct substitution set up where I've plugged in negative 1 for all the x's, and we're going to go ahead and do this together just so I can talk you through it again so you can feel more confident that you can do this without a calculator. So negative 1 to the fourth, that's negative 1 times itself 4 times. So we'll go through this step by step. Negative 1 times itself is positive 1. You multiply it by negative 1 again, you're back to negative 1. And when you multiply it by negative 1 again, you're back to positive 1. So remember, you've learned this pattern before, that an even exponent is going to give you a positive number in the end. But you may want to just go through it step by step at this point. So negative 2 times 1 is negative 2. So there, we've simplified that term without a calculator. Yay! Okay, the next term, negative 1 cubed. So we kind of just walked through this. Remember, that's going to get us back in the negatives. So that is negative 1 in itself. But remember, we're subtracting because of this minus here. So that ends up being plus 1 because it was minus negative 1. Okay, our next term, we're getting a little bit easier. 4 times negative 1 is negative 4, minus 5, and then we're just simplifying this. So negative 2 plus 1 is negative 1, minus 4 is negative 5, minus 5 is negative 10. And check that out. We got the same answer that we got doing synthetic substitution up above. So we know that we did that correctly. Which way are you starting to like better? I personally like synthetic substitution better. Maybe at this point it's not your favorite, but I think later on it will be. Either way, however we do this, whether we do it synthetically or directly, we get this answer of f of negative 1, as in the function value when the x value is negative 1, is negative 10. And that tells you, if you'd rather think of it like this, you've got an ordered pair on your function at negative 1, that's the x value, negative 10. Okay, so we do use this to actually graph these polynomials to get specific points on them. Alright, so here's another example where we're going to use synthetic substitution to evaluate a polynomial when we're given an x value. So here's our polynomial. F of x equals negative 2x to the fourth plus 3x cubed minus 8x plus 13, and we're evaluating when x equals 2. So again, let's just take this in, check out this polynomial function we've got. The highest power, the degree, is 4, so remember this is a quartic polynomial, and our leading coefficient is negative, so that tells us something about the end behavior. Remember, we learned that this is going to act just like a quadratic would because it has an even exponent and a negative leading coefficient. That means it's going to be a quadratic that opens down, and it's a quartic here. So it may look, because it's kind of a messy thing, it may look sort of like that lopsided W that we saw in the notes last class when we learned about end behavior. So just keep that in mind, that you already know some stuff about these quadratics, but what we're focused on right now is actually evaluating this. So this time you guys get the treat of setting this up to do synthetic substitution, and I've shown you a little bit. And keep in mind, you want to have this in standard form, which it already is. We've got x to the fourth, we've got x cubed. Do you guys see that we're missing the term with x squared? So make a note of that. Take a minute to take in your polynomial and check out what's going on there so you can remember placeholders. Then you'll move on. Here's your x term, here's your constant, okay? So all of our coefficients are in order: negative 2, positive 3, 0 for my x squared term, negative 8, and 13 my constant. Okay, I'm going to draw my little box around it, and I'm going to put a little line here because that's going to remind me, okay, I'm done, I got my function value. And we are going to put this x value, x equals 2, on the outside because that's what we're plugging in. Okay, so let's see if you remember this routine. You can go ahead and pause the video, see if you can do it, and then I'll run through it real quick after you try it. Alright, so hopefully you tried this on your own. Remember, you bring down the first number, multiply by the number outside, so negative 4, add, you get negative 1, multiply, you get negative 2, add, negative 2, multiply, you get negative 4, add these, you get negative 12, multiply, you get negative 24, and then add them and you get negative 11. So there we go, that is our function value, okay? So we know that f of 2 equals negative 11, okay? In other words, you have a point on your function at 2, negative 11. It's just kind of nice to also think of it as an ordered pair. I'll have you doing that on the next page, so I'm getting you warmed up for this. Okay, so let's check out another example, and this one is really fun because I'll point out that it kind of fits in with our factoring patterns that we've already learned. So we want to evaluate this function when x equals 3, and because this one's pretty basic, it would probably be pretty quick to also do direct substitution, and we'll do that after we do the synthetic substitution just to check it. But let's just take a minute, like I've had you guys do for the past couple examples, and take this in. So we've got this polynomial. We see that the highest power is 3. It's a degree 3 polynomial, which means it's cubic. And notice that it's missing an x squared term and it's missing an x term. So when we set up our synthetic substitution, we're going to need placeholders for both an x squared term and an x term before we get to our constant. Okay, so let's go ahead and do that. We need our coefficient for our x cubed term and we need our constant at the end. I'm just kind of showing you guys how this is set up. So our leading coefficient for the cubed term is 1. Here are our placeholders, and our constant is negative 27. Okay, and we draw our little box around it. We put our little line kind of in line with this last number. And on the outside, remember, we put the number that we're putting in. So in this case, that's 3. All right, so again, go ahead and pause the video, see if you can do this on your own, and then play it when you're done. All right, so hopefully you did this on your own. Remember, bring down, multiply, add, multiply, add, multiply, add, and we get 0. So this time we got a function value of 0. And we'll kind of keep playing with this next class. And I'll bring up this example next class too, and you guys will see how this plays into something that you guys already know about factoring this. Remember guys, you already know how to factor this difference of 2 cubes. We'll get into that more next class when we get into more detail here. But what we have is f of 3, our final concept here is f of 3 equals 0. That means that if you are graphing this, you've got a point on your function at x equals 3, x value is 3, and y is 0. Okay, so somewhere over here. What do you call that? Think about what that special point is. Okay, so what did we just find? We found a 0, and that's something really crucial that we're going to use some more next class. But synthetic substitution can be used to find zeros of a function. For example, this is a 0 of a function. So keep in mind, when you get a final answer of 0, you found, a 0 of a function. So to fill in that blank in your notes, just in case that wasn't clear, synthetic substitution can also be used to find zeros of a function. And if you also want to write yourself a little note, that's when the y value is 0. That's when you're crossing the x-axis. So just to solidify these concepts, I've got a couple more examples for you guys. I give you a new function, and let's just take a moment to take it in. We've got our polynomial here, 5x cubed minus 8x squared plus 5x minus 1. Our degree is 3, so this is a cubic polynomial, and our leading coefficient, which is positive, tells us that we're going to have this end behavior. And the whole point of evaluating is so that we can find out more stuff that's going on in between what's going on the ends as x approaches negative infinity and as x approaches positive infinity. All right, so we're going to use direct substitution, and remember this is the classic way that you know how to evaluate a polynomial when x equals 2. So that means just simply plugging in 2 for all the x values. So your work should look something like this, and we'll do this together just to show we can do this without a calculator. Have faith in yourself. Okay, so let's get started. 2 cubed, that's 2 times 2 times 2, that's 8, times 5, this 5 out in front is 40. Look, we just did that whole term. Okay, next, remember order of operations, we've got to do 2 squared first, so we know 2 squared is 4, and times negative 8 is minus 32, okay? Our next term, yay, it's getting a little bit easier. 5 times 2 is 10, minus 1. So 40 minus 32 is 8, plus 10 is 18, minus 1 gives us 17. So there's our classic direct substitution, okay? So if we want to write this as an ordered pair, like I've had you guys do before, 2, 17. The x value, that's what we plugged in, is 2, and the y value, what we got, is 17, okay? Writing this in function notation, that's kind of the way we were writing it previously also. That is f of 2, as in what's the function value when the x value is 2, and that's 17. And like we saw in the last example, when we got 0 at the very end as our function value, the y value, then we knew that it was a 0 of the function. If we get a y value of 17, we know that we are, up in quadrant 1. If we've got this ordered pair at 217, we're somewhere over here. That's not a 0. Visualize it. So is the ordered pair 0? Our answer to that question is no. Okay, so now we're going to practice synthetic substitution. Same function, but we're going to do this when x equals 5. Okay, so we set this up. Pause the video and see if you can do this on your own. Okay, so here's your setup with your coefficients, 5, negative 8, 5, and negative 1. And go ahead and pause the video again if you've got that correct setup, and see if you can evaluate this. So those numbers were a little bit bigger, and And that would have definitely been harder to do direct substitution there. So here is our final answer, and we can kind of talk about this a number of different ways. We can write this as an ordered pair. The x value, remember what we plugged in was 5. Our y value, our final answer, was 449. So there's our ordered pair. Function notation, f of 5 is 449. And is this a 0? Well, again, visualize it. We're over, x value is 5. We're way up here. I didn't draw this to scale, but I didn't even give you a scale, but we're way up off the x-axis. So to answer that third question, is this ordered pair 0? No, it's not a 0. Okay, and just to finish up this video, your next example, your final answer as an ordered pair, because you plugged in the x value of -2, you should have -2, -83. In function notation, f of -2 is -83. And again, to answer that question, as long as you didn't get a y value of 0, it's not a 0. Okay, so hopefully you did all that on your own just fine. And now we're going to move on to another concept in the next video. So hope you enjoyed your introduction and practice of synthetic substitution.